All right, it is now 6 o'clock and we're about to start. We're about to start. All right, tomorrow is the exam. And we have a number of things to go through as we go forward. All right, let's just check. All right, let's go. All right, so here's a typical number one question we want to look at. So here goes. It says, using the calculator or otherwise calculate the exact value of, and we have a fraction here to deal with. So we're going to be dealing with this fraction here. So it says 1 3/4 square, and you want to divide that by 3.5. What we normally encourage you to do before you start working these is that you want to convert all your mixed numbers to improper fraction to have a better idea first. All right, so we want to change these and then change that. So let us go ahead and just change it first. All right, so what are we looking at? We're looking at 414 plus 3. That's 7/4. We're going to be squaring that. And we want to divide that by 326 plus 1, 7/2. All right. So at this moment, what we're going to do is to square the first one. And when you square, it simply means that the 7 will be squared as well as the 4 will be squared. All right. So that's what we're going to be having there, right? So we're going to be squaring the 7, squaring the 4. So we're going to get 7 7s, 49/4, 16. That is what will be divided by 7/2. All right, so what we're going to do at this moment is just simply to change our division sign to multiplication, and then we're going to reciprocate the fraction at the back. So we're going to get 2/7. And then we want to employ some canceling because 2 into itself 1, 2 into the 16, that's 8, 7 into itself 1, 7 into 49, that's 7. 7 1s, 7 at the top, 8 1, 8 at the bottom. All right, so our final answer would have been 7 8. All right, quite easy. We don't want to drop those marks, right? We want to drop those marks. Expressing that as a fraction, that's a 3 marks right there, easily. All right, so check it out. We got 7 8s for that. All right, let's look at the next one. We're supposed to find the square root of 0.0529 plus 0.216. All right, so what we want to do at this moment is to use our calculator. So we want to show that we can use our calculator well. So 0.0529, you want to put this on your calculator, and we're going to get 0.23. You want to add that to 0.216. When you add that, we're getting 0.446 for that. But be careful now. One has to read to see exactly what they want. It says expressing your answer in standard form. What you don't want to do is to leave it like this. Standard form. So if we're going to put this in standard form, definitely the decimal point must come after the first digit that is not a 0 from left to right. So it's going to come between the 4 and the 4. So we write back 4.46 times 10, and we're going to raise that to some power. But the power of 10 will depend on how many times we move this decimal point for it to get there, and that's 1. So this is the power of 1. However, your 1 can be positive, it can be negative. A lot of people would say if you're moving from left to right, it's a negative. As well as we might say if the number that you change into standard form is a 0 point something, it is already a negative power of 10. Whichever way works for you, then it's fine. So the answer is 4.46 times 10 to the negative 1. All right, so for the B part says a typist is paid a basic wage of $22.50 for a 40-hour week, right? So we're looking at $22.50 for 40 hours, all right? Now, then the question says, calculate the typist's basic wage, $22.50 for 40 hours. All right, let us take a look. So we're getting $22.50. All right, so $22.50 per hour. And this person is working a 40-hour week job. So on a normal basis, they're working for 40 hours, right? So $22.50 every hour, and then you're working for 40 hours. So here's the first question. Calculate the typist's basic week, all right? Basic weekly wage. So your weekly wage is very straightforward. It's gonna be your hourly rate, yeah? We call that your basic rate. And you want to multiply that by the time that you normally spend, all right? So we wanna multiply that by your basic week. And this part refers to the time that you spend. And this is normally in hours. So we're talking about $22.50. You want to multiply that by 40. You're making $22.50 per hour and you work for 40 hours. So it's very straightforward. You're making about $900 there. So the typist is making $900 weekly, right? So on a weekly basis, $900. These type of questions come at number 1, very straightforward in terms of what you have to do, all right? Now, so we found out that we're making $900 there. It says overtime is paid at time and a half. So when we talk about overtime, talking about you're working extra hours, and normally when you work extra hours, they normally give you a little bit more. So when they say time and a half or 1.5 times, it means then they're going to change your hourly rate by 1.5 times, right? So let us look here. So your hourly rate, your normal, this is the basic rate. Your basic rate is $22.50. Now you're going to be working overtime. There is some agreement for overtime. We call that the overtime agreement. So the overtime, can I write OT for overtime? So your overtime agreement is 1.5. So they call that time and a half. So then your overtime rate will be different. So look at what they want. They are saying calculate your overtime wage for 1 hour. So how much would you make for 1 hour? Well, all you have to do is to find out your rate for that hour. Let us take a look. So now my can I write OT for overtime rate? So this is referring to how much I'm going to make per hour. It's going to be this $22.50. They had planned to give me 1.5 times that. So you multiply your $22.50 times 1.5, and now you're making actually $33.75 every hour, right? So this is This is technically the wage you'll make in 1 hour. This is the rate per hour. So the question, look what the question says. Question says calculate the overtime wage for 1 hour. It's going to be the same thing here, all right? Because it's just 1 hour. So you want to say that, all right, my overtime wage for 1 hour is just going to be $33.75, because that's the amount I'm working for 1 hour and overtime. I did 1 hour, I'll get that alone, right? So that's what you're getting on overtime. That's the overtime rate. 1 hour of it, we get that money, all right? So it's very straightforward looking at what you have to do. Take your time when you're working these, all right? Try not to make any error as you go, right? All right, so there it is. We look at this right here. Now, moving on, it says to earn extra money, the typist decides to work overtime. So now you're seeing the typist going to work some overtime now. Here is the question. The question says, let me put the question in a clear, all right, good. So the question says, calculate the wage she would earn for overtime if she worked for a total of 52 hours. Here comes the question, because now this person will now work for 52 hours. All right. And then we watch what they want. The wage she would earn for overtime, not overall, just for the overtime. So we want to put the thing into perspective. Don't just give the gross. You want to give what they ask for overtime, the wage for overtime. All right. So 52 hours she planned to work. So let us take a look at this. Now, for 52 hours, right? If you normally work 40 hours and you work 52 hours on a given week, you're going to realize that you just work some extra time, because normally you work for 40 hours. So you are able to tell the overtime hours right now. We can tell the overtime hours right now by subtracting the 40, which is the normal hours, from all the hours she worked that week, and we're going to get 12. So in other words, then this person worked 12 hours extra, right, on overtime. So this is the hours that you work. Now, take a look at this. If I know the hours that I work on overtime, and if I know my overtime rate, we just found it, $33. So on overtime, I'm working $33.75. Then I am able to tell my overtime wage. So my overtime wage is going to be my overtime rate times the overtime hours. So it is very straightforward. I'm working $33.75, and I did it for 12 hours. So on overtime, I will collect $405. Make sure you're checking with me so that we make no errors as we go forward. So on overtime, all right, the typist would have worked $405 exactly. We're talking about putting the things in the right perspective, understand the hours you did on overtime, linking it back to the rate you're being paid per hour. It's a simple multiplication. You know the amount of money you expect to get on overtime. All right, let's see the other question. The next question says that.
Sir?
Go ahead. You want to see about the next page?
Never mind, sir.
All right, you're good. All right, good. It says the number of overtime hours she must work during a given week to earn a total wage of this. So now the question switch. The question is saying that we want to know the hours that she needs to work to earn this amount, the hours. All right, so there are a number of things that you can do here. Now, they never said, you know, we don't want you to think that they say to earn overtime wage. That's not what they're saying. They're saying to earn in total. That means everything for that week. Well, I'm going to have to take some time out to find out how much money would I normally make that week on a normal basis, right? So let us look at the question in perspective here. Let's go. We're thinking about a total wage, and this is like what we call your gross wage. And that would have been everything, overtime plus regular. It's going to come up to 1,004. Let me look if it is correct. 1,440. We're thinking of what hours do I need to go on overtime so that I'll get this on my paycheck. Well, firstly, we need to know our basic first. Remember your basic wage. You found it already to be $900. Your basic wage for that same week. We found it to be $900, so we don't have to work it again. Let's go for it. It's up there. See there? Our basic or our weekly would have been $900 already. We know that. So now we're talking about, we want to subtract. So we want to see the overtime money first. Let us see the money on overtime. This overtime wage would be equal to my normal money being taken from the total. So my normal 900, I'm going to take that from the 1,440. So when I do that, I will be making $540 extra. So this is overtime wage. Now, if I have overtime wage and I know overtime rate, which was $33.75, I can definitely find my overtime hours. Yeah. My overtime hours can easily be calculated by dividing my overtime wage by the overtime rate. Think about it. Divide the wage by the rate I'm working. So you're talking about 540 being divided by 33.75. And if I do that, I'm definitely going to be seeing the hours that it would take. And this will take me 16 hours on overtime to pull that off. So these questions do come, you know, so at number one, you're looking for some numbers, some rounding off, some fractions, some stuff like that. Then consumer math, which can be anything like wages, percentage, and so on. So we're looking for that. All right. So definitely you have to just read, take your time, and put it together properly. Let's look at a typical number two. We're looking at an algebra question. All right. We probably could do this one right here on spot. All right. So this algebra question here is asking for us to substitute, right? So what we have a squared plus b all over c minus b. Well, let us substitute. A6, so if we have a squared, we're talking about 6 squared. You want to add b to it, and b is, I'm going to put it in a bracket. So that's a negative number, and that is going to be divided by c. And what c is? C is 8, and we want to subtract b, but b again is a negative number. So you want to make sure that you show respect to the idea. I put that negative number in a bracket. I don't want to mix it up with the operation. So so a lot of times people just put down one thing here without carefully analyzing what they're doing. So what we want to do at this point is to work 6, 6, 36 plus minus. When those two signs clash, it's going to come out as a negative 4 over. When these two negatives clash, it's going to come out as a positive. So that's going to be over 12. So we're talking about 32. All right, so we have 32 over 12. 32 over 12, you could break it down if you want. You can break it down if you want. You could use 4, and you'll get about 8 over 3, and I'll leave it right there. All right, calculate, show the value of that. So it's 8 over 3. If you break it to decimal, you might get 2.66667. All right, so I'm fine with my improper fraction 8 over 3. Just divide everything by 4. 4 into that 8, 4 into that 3. All right, very simple substitution. But if you notice though, they squeeze in this negative thing a lot. And if you're not very, very focused, you might make a mistake. We don't want to do that. All right, the next question says, simplify. As you could see, we want to simplify the expressions here. What we want to do is to employ our distributive property. We want to distribute. So the 3 will distribute to the x. The same 3 will be distributed to that negative y, positive 4 to the x, positive 4 to the 2y. We want to do that. All right. So what next? We could do it beside it. So when we have the 3 times x, we'll get 3x. The 3 times negative y will give you negative 3y. 4 times x will give you a positive 4x. And the 4 times 2y will give you positive 8y. You want to group your like terms. It's 3x plus 4x. There is a negative 3y plus 8y. So this becomes 7x. And then the negative 3, the positive 8 will give me a positive 5y. So right there, we're seeing 7x plus 5y. And that's where you stop for that one right there. Remember that the x and the y cannot be added. Sometimes people want to go further. You cannot. You can only add or subtract terms that are alike, and what makes them alike would be the same variable. All right, let's look on this one here. Could just put it at the side. It's a very small thing to do. So we have 4x squared, and we're going to multiply that by 3x to the 4th, and that will be divided by 6x to the 3rd. I'm just going to go through. I could cancel now and then do multiplication, but I'm just going to multiply, then cancel at the end. All right. So at the top, 4 3s will give me a 12. And then x will raise to the 6, because remember, when you multiply the same letters, you add their powers. So that's a 6. I want to divide that by 6x to the 3rd. At this time, I could employ some canceling. For example, 16 to itself 1, 16 to the 12 2, and x to the 3rd will cancel 3 out of that 6, leaving 3. What's my final response? I'm left with a 2x to the 3rd over 1, which is just 2x to the 3rd. Final answer. All right, so you cancel down, fine, and you see what's happening there. You could go. All right. All right, so we have an inequality there that we want to solve. Solve this inequality right here. All right, so let me write it. X minus 3. Let me go up some more, give myself some space. So the inequality says we have an x minus 3. And we have less than 3x minus 7. All right, just double checking. X minus 3 less than 3x minus 7. Good. All right, so the idea is that we're supposed to solve that. I would say to you that when you're solving inequalities, it is solved ordinarily. All right, just as though you solve an equation, except if you divide or multiply by a negative number, you flip the sign. All right, but if that doesn't happen, you just work ordinary. So what we're going to do, I would just suggest that, listen, you decide where you want to keep the x's. So let us say I want to keep the x's on the right side where it is right now, where the 3 is, if I want to do that. So it's up to me. So all I'm going to do, I need to minus x there, and I would minus x there. All right, so let me just take my time and work it timely. On the left side, I will have -3 less than. So 3x minus x becomes 2x, and there's a -7, right? So after the first move, that's what I'm looking at. I'm going to try to get rid of that 7 right there. So I'm going to add 7 because it's a -7. I'm going to add 7 to the other side. So a -3 and a +7 will give me +4 less than, and we have 2x. At this time, I want to divide both sides by 2. So then 2 is less than x, or you could read it and say x is greater than 2. Same thing, because if 2 is less than x, that means x is greater than 2. So that would be your solution. If you do notice that everything remained the same, right? We didn't do anything, the sign remained the same, still remain the same, still remain the same. This is the same thing, I just turn everything around, but I didn't flip the sign, right? So if this one is confusing you, we could take it off, all right? Because it's done right there. So if I'm reading it from this side, it says x is greater because it opens to the x greater than 2. But if I'm reading it from this side, I will say 2 is less than x, right? So that is why I was saying, oh, you could say x is greater than 2 if you feel comfortable. That's fine. Now let's see what they want us to do with this solution. All right. So we just found out that x is greater than 2. All right, x is greater than 2 right there. Hold on, it's a little bit big. Let's bring it down. All right, good. So x is greater than 2. So here's the question. So the question says no. If x is an integer, determine the smallest, be careful, smallest value of x that satisfies the inequality above. Let's take a look at it. X is greater than 2, and we want the smallest possible solution. If x is greater than 2, the smallest possible solution here is that x is a 3. That is the smallest one. Greater than 2, 2 is not a part of the deal. So the next integer, because they did say integer, there's no decimal, no fraction. So x is equal to 3 would have been the smallest integer that satisfies the idea. 1 mark, you gone.
Excuse me, sir. Could you read the question to that again?
Oh, the question says, if x is an integer, determine the smallest value of x that satisfies the inequality in CI, which is the question we just did. Because the solution that we got was that x was greater than 2. So if you're thinking about numbers greater than 2, and if it is an integer, what are integers? Integers do not have decimals. So you're talking about 3, then 4, 5, 6, and 7, and it goes on like that to infinity, right? So what would have been the smallest possible solution? 3. So that's what we're saying. Based on the question, x would be 3. It's the smallest possible one right now.
Thank you, sir.
All right, appreciate it. All right, let's now continue. Now we're looking at using up some tricks now. We want to use some tricks. Tricks is all over your paper. So let's see what this one is. It says here, the diagram not drawn to scale shows 2 straight wires, talking about LJ and NK. LJ and NK, you're seeing those, right? Supporting a vertical pole, MJ. Now they're saying that LMN is a straight line on an horizontal plane. Angle JML is 90, you're looking at it. KNM is 30, you're seeing it. And they give everything else, the 13, the 5, and the 10. Now let's see the question. I think I could do this question right here, all right? First question, it says calculate in meters the length of MK. This is what they want you to find, MK, right here. Right there, that little green spot right here. Definitely MK can be found by utilizing the fact that there is a right angle triangle here, because you're seeing the 90 degree over here. This is 90 as well. So it's a right angle triangle with one angle, one side, to find the side opposite to the angle. So 30 degrees, the opposite side is what we want to find. And we do have the hypotenuse. So we have the hypotenuse, yeah, and we're in search of the opposite. So now you want to draw back on the soccer tower, right? So you want to draw on your soccer tower, and then you want to think of, when you pull back on that, what will be, yeah, what will be, which one of these would have the opposite and the hypotenuse? So you look, it's going to be sine. So you want to set up this, that the sine of an angle in the right angle triangle is equal to the opposite side divided by the hypotenuse side. Now the angle is 30. So the sine of 30 degrees is equal to mk over 10. And from here, you could easily multiply both sides by 10 so that you'll find the mk alone based on what we have. So mk, we could write it like this now if we want. Mk is equal to 10 times the sine of 30.
5. It's 5.
Please make sure that you put your calculators in degree mode. All right. Please make sure you put your calculator in degree mode, and you would get 5 meters for that. Right. So this side is 5 right here. All right, I'm going to put it on it. This is 5 right there. All right. Next question. We want to find JK. So we want to find the distance from here to here. I want us to take a quick look at what's going on. We're looking at a right angle triangle with the sides 13, 5. It simply means that I can find all of this side here. But I don't want all of it. I'm going to want from K to J to K, which means that when I find all of ML, I'm going to subtract the 5 from it. In other words, our intention is to understand that JK is equal to MJ minus MK, right? So if I find MJ and then subtract MK, I will have from J to K. So let us go about finding that big side MJ. Remember though, it's a right angle triangle. It's one of the short side. The longest side is 13. So I could just start off by saying 13 square is equal to 5 square plus MJ square. 169 is equal to 25 plus MJ square. Subtract 25 from both sides. 144 is equal to MJ square. Taking the square root of both sides, 12 meters is equal to MJ. So if I know that MJ is 12 and then MK is 5, remember that JK equals 12 minus the 5, which is 7 meters, and you're done. So you just want to put the things the right perspective, and then you want to push forward. You're good. All right. All right, let's continue working and looking at more ideas. Oh, I think I have a nice thing that I haven't seen in a while right here. So, all right. This one here is a similar triangle, right? Can come at the same place. They could send this instead of the one that we just saw. So it says in the diagram below, not drawn to scale, AEC and ADB are straight lines. All right, so you're looking at ABC and you're looking at everything that they're saying. All the angles and the measurements that you're looking at here, it is on the diagram. Now, first question says, calculate the length BC. Look at BC. Here is BC. As you could see, it's a part of this big triangle right there. So I'm seeing that triangle and I realize that I have the sides. I have 10, I have 8, and it's a right angle triangle. Now, the longest side is 10, which means I could start off by saying 10 square is equal to 8 square plus BC square. So the longest side square is equal to the sum of the other two short sides square. Let's put our numbers together. 10 square is 100. 8 square is 64 plus BC square. In an effort to find BC, let us subtract 64 from both sides. I believe I'll get 36 is equal to BC square. Now, the value of BC is to take the root of both sides. 6 meters is equal to BC. So we utilize the Pythagorean theorem there as we went forward in executing that. So let us just put it on. I'm going to put it right there, 6. So here it is, 6 meters. Now let's follow through. There's a 1-mark question here. All right, and it says explain. All right, this one says explain why triangle ABC and triangle ADE are similar. All right, I'm happy that I see this question. As similar triangles are the result of an enlargement. Please be advised. When you see this being used, it's coming from the concept of an enlargement. And you know that with an enlargement, it's the same concept stretched bigger. So then let's isolate the triangles. Let me try to point them out. There are 2 triangles here, right, that they're referring to. They said ABC, which was this one that we looked at, A to B to C, that's the big one. And I'm going to try to use the pink to override a smaller one. Smaller one is ADE, so some of it will overlap. So it's like the pink one was enlarged, all right, to the green one. Or the green one enlarged and shrinks to that one, any one. But basically, the concept behind similar triangles is that they will have the same angles inside. So that's the concept for similarity. When triangles are similar, when anything is actually similar, the angles are the same inside. So then, because it's a 1-mark question, look what they said. Explain why, right? So if you want to explain why here, I'm telling you, take a look. Let's look at the angles. So when you're explaining similar triangles, all you have to do is look at the angles. Look at angle B, it's 90. Look at angle D, it's 90. Both of them, they have A. Both of them, you know, they have A. A angle is a part of both. So if both of them have 90 and 90 and then A is the same, automatically this angle is the same as that angle. So you realize that the big triangle and the small one, they have the same angles inside, and that is what makes them similar, right? So explain why triangle ABC and ADE are similar. We could simply say that they have the same angles. Angles are what makes things similar. And there is another thing near to similarity which overlap it and go further, and it's called congruent. All right, with congruent, it's the same size. So everything congruent is already similar, but it's more unique where the length of the sides are the same. Most times when things are similar, the length of the sides are different. Like these, one is bigger than the other. But if you should have measured the angles singly, you would have gotten the same thing. And that is what they want here for the mark. Same angles inside. Let's look at how do we utilize similar triangle now to solve a problem. It says determine the length DE. Now let me clear up the diagram so that we could focus. When triangles are similar, guys, bear in mind that it's an enlargement, which means that it was affected by a scale factor, right? And the same idea that you treat enlargement, you're going to treat similar triangles the same way. Now we want to find DE, and I'm going to highlight it with a red, with a pink right there. Would you agree that that side corresponds with that one? So those are the matching sides, right? So we're going to take note of that. We're going to be using it soon. Now, what else are we going to be using? We're going to be using the fact that the long side for the big triangle is 8. The long side, that means when I say the long side, I'm referring to, let me not say long because I don't want to say the longest side. I'm referring to the fact that AB right there is going to be corresponding with AD. AB correspond with AD. Similarity. Just as how DE correspond with BC, A to B links to A to D. So those are like what we call image and object, all right? So here is the deal. Would you agree that if I want to find AD, I will simply say 8 minus 3.2, 8 minus 3.2, and I'm going to get 4.8 for AD. A to D is simply 4.8. Tell me if you agree. A to D, 4.8. Now, when you're going to manipulate a similar triangle or an enlargement to find a side, when you don't have certain stuff, you're going to form relationships like this. Let's say we're putting the bigger one on top. 8, before I go 8, let me write the idea. AB divided by AD would give us what we called the scale factor. It is also equal to the same thing as BC, which is the bigger, over the corresponding. So we're saying that if you put AB over AD, the same number is going to equal to if you had put BC over DE, because you're putting the bigger over the smaller, but you're making sure that they correspond. So because of that, we can do this. We can use that notion to solve a problem. Here is how we're going to solve the problem. AB is 8. You want to put that over AD, 4.8. It is equal to BC, 6, over what we intend to find, DE. So a lot of times when you're going to manipulate a similar triangle, they're going to give you two pairs of things. One pair you'll have both numbers for. And then they're going to give you one to find the other of a corresponding. For example, we got the 6 and we need to find the corresponding side. All you have to do is to apply regular math and say cross multiplication right now. This time this is going to equal to that time that. Regular. So don't be afraid to utilize all those little things that you learn. So I'm suggesting that 8 times DE is equal to 6 times 4.8. If I want to find DE, I'll divide by 8, divide by 8. Check it out. DE is equal to 4.8 times 6, then divide that by 8. Anything you get is the answer. It says 3.6, and definitely that's the answer. All right? So that is how you kind of, I'm not saying this is the only way to work this, because I could have worked this 2 more ways. All right, but I'm just giving a kind of a general idea that as long as you set this up, you will be able to find the one unknown, because you're going to be having a pair of known sides. And then they're going to give you one and ask you for the corresponding one to that. That is how they set these questions. And that is how they can be worked, right? All right, let's continue working. So that's a similar triangle. If take some time, if you have to come back to the video and go and take a look at it, fine. But you can treat it like an enlargement. So what I'm suggesting here is when you're dividing the big side over the corresponding small one, that is actually giving you what we'll call K, your scale factor. That's what it does. And that is why we could have said it's equal to BC over DE. And I could went further and said it's also equal to AC over AE. Take a look. From A all the way to C divided by from A to E. So you're seeing we're linking the corresponding sides of the two triangles that we're comparing. And if I'm putting the bigger one on top, I have to do it until this problem is finished. All right. If I'm putting the smaller one on top, I have to do it until the problem is finished. Don't be switching around. So that's why I held my bigger numbers on top all the way. 8 over 4.8, 6 over 3.6, like that. All right, guys, let's continue. Let us continue. All right, coordinate geometry. It's on the paper every year. All right, I've never seen a year without coordinate geometry. If they don't put it at number 4, it's gonna definitely be at number 8. So it is there. All right, let's read through, see what they want, and then we apply ourselves to it. It says the diagram below represents the graph of a straight line which passes through the points P and Q. You're looking at that. Here is P, here is Q, right? So you could see that it passed through those, right? Now let's continue to the questions. Here are the questions. First question, let me blow that up. The first question says, state the coordinate of P and Q. All right, so we're gonna write the coordinate of P. We could write P here and Q. We could write them right here. State the coordinates of P and Q. Let's go back and take a look at it. Coordinates, P and Q. They love to give these because people tend to make mistakes. P, we're looking at P right here. Please remember that you read the X value. On the X axis, 0 meets 3 on the Y. So that's the order. X value first, then Y value after. So you're talking about P is a 0, 3. And then Q is a 2 on the X, meeting a 0. So you have to look at your horizontal lines, then the vertical. So it's a -2 with a 0. And those are the coordinates. And if you notice, you got 2 marks, 1 for each. Very nice, very easy. Giveaway marks, don't want to miss those. Now we have picked those points. They say, determine the gradient of the line segment PQ. All right, it seems as if I could work the gradient of PQ there if we want. All right, we could work it also. All right, so P was a 0, 3, and Q was a -2 with a 0. Now, we want to find the gradient PQ. Please be reminded that when we're going to find gradient, right? What you want to do is to take some time to label your points quickly. X1 walks with Y1. You might be asking which one is X1, anyone you decide. But make sure X1 walks with Y1, and wherever you pick X2, it walks with Y2. Remember though that the gradient formula deals with changing Y over changing X. And when we say changing Y over changing X, a lot of people will say the rise over the run. So the change in the Y, we're talking about Y2 minus Y1 at the top over the run, which is X1 minus X2 minus X1. Yeah, I fixed it. Thank you. So now let us do the substitution. Y2 is a 0 minus Y1, that's a 3, over X2, -2, minus X1, 0. Continue. 0 minus 3, minus 3, over -2 minus 0, that's a minus 2. What are we looking at? 3 over 2. All right, so this is my gradient. 3 over 2 is my gradient. So the gradient of PQ is 3 over 2. All right, another, you know what? I'll just point to ideas too. I never had to have gone all through that. I'm just saying, look, if you look at the line, since it is on a grid, if you're looking at it on a grid, you can find the gradient also by picking off a proper right angle triangle where you are able to count the vertical and horizontal sides. For example, I would have marked off this. And if you look at where I'm marked off, I'm able to count those sides properly. Here is the right angle. I'm able to count the vertical sides to get 1, 2, 3, that is 3. And the horizontal, I'm counting the side 1, 2 units, 2. Remember, gradient is changing y over changing x, rise over run, and you still would have gotten that 3 over 2, just the same. It's just that you need to understand when the line is negative from when the line is positive, right? So this line is a positive line because it's like climbing a hill from left to right. And if you're coming down a hill from left to right, it's a negative. But this one that the question gave was actually a positive gradient because it's like you're going up a hill. So if you don't feel like to calculate it and you're looking at it, you can definitely employ counting and get the gradient just the same, 3 over 2. Additional information. All right, so we looked at the gradient here. Now, what about looking at the next question now? It says, so you want to determine the equation of the line segment PQ. Well, when I get things like this simple, I'm not going to do much because the idea is already there. What do I mean? This is what I mean. Take a look. If I'm going to write the equation of any line, I want us to pay attention to details. Now, I am looking at the line, right? We found out by calculation and by counting that the gradient is 3 over 2. I need the C value because 2 things I need to write the equation of a line. I need the y-intercept, which is what we call C, and I need the gradient, which is what we call M. We have the gradient. Look if you see the y-intercept. Look, you would have noticed that the line crossed the y-axis at +3. That means I'm not going to try to work out to get 3 because I have it looking on. So I'm suggesting if you're looking at the y-intercept, do not waste your time in the exam. All right, just utilize it and move on. For example, at this moment, we're seeing that C is 3. So if I have my gradient and my y-intercept, then the equation of the line is y equal to 3 over 2 with x and a +3. And you get 2 marks for that. Freeze up. And there it is. Quite simply. Go ahead.
Pass when I did them. I just pass I give some to get it in a chair.
All right, good. Remember to watch the mics, please. All right. Now, here's the fun part of the question. The C part says this. C part. The C part says the point -8t lies on, thank you, lies on the line segment PQ. All right. So -8t. So obviously they are hiding a value, which is the y value. So they are saying to us, can we determine the value of t? Now I'm going to say this to you. Whenever you have an equation of a line, it is stating a very profound, a very deep message. The message that it is telling you is that every single point on that line is obeying this order. And the order is that if you take the x value, multiply it by 3/2, and add 3 to it, it will tell you what the y value is. Read what the equation says. Y equals 3/2 times x plus 5. Forget about equation. Think about what it is saying in algebra. The value of y is equal to 3/2 times x plus 3. Oh, so then if I am given -8, let me put it at the side. If I'm given -8t, for me to find the value for t, and I'm told that the point is on the line. This is the thing, you know, if it was not on the line, you could not have done this because this is the order for that line. Watch this. Let us employ substitution. Y is called t. I'm going to put it where the y is. So remember, this is your x, this is your y. So I am able to put the t where y is. So I have 3/2 times x, but x is -8. I'm going to put -8 here, plus 3. Take a look at what we just did. After substitution, the only unknown I have is the value, is to find that value t. Let's go through. I realize I can cancel, I'll do it. So 2 into itself is 1, 2 into the -8 is -4. Let us simplify this. 3 times -4 is -12, and then I'm adding 3. This is going to leave me with a -9. T is -9, and that's what it is. So this is saying that when x is -8 on that line, t is definitely -9, right? So that's what that is saying right now. So I want to appreciate that as we go forward, all right? T is 9. So remember this, the equation of the line has its meaning. Utilize it when they try to do things like this. So you don't have to be thinking like, what do I do? Substitute those things in the order of the line, which is what I'll call the equation that governs the movements of that line. All right, let's continue looking at more questions. They want us now to write, right? So the line segment AB, new thing, the line segment AB is perpendicular. Let's highlight that word right here. It's perpendicular to PQ and it passes through 6Q. All right. So they want us to determine the equation of that line in this format. All right. Let us drop that line on my grid. It's perpendicular and it passes through 6Q. All right. So what they're saying is that there is some perpendicular line, right? I may not get it past through 6-2, but I could. I think this would have been 6-2 here, something like that, right? So they're saying that line is right there. Hold on. Let me drop back the line. All right, so the line is perpendicular. All right, some line. So I'm just giving an idea. So we have some line perpendicular to our original line, and it passes through 6-2. So I'm just saying to us, this is our point. This would have been 5, that's 6. You don't have to draw it in. I just want you to have a visual of what's going on. So we're looking at this. So what we're suggesting in that A right there is a right angle. All right, we're just making up. This is not properly done, but I'm saying this is the idea. It is perpendicular to PQ, and then it passes through 6Q. No problem. One of the things about perpendicular lines, I'll probably just work it right here on this, right? The thing about perpendicular lines is that there is a specific relationship between their gradients. So I'm going to write PQ's gradient now. PQ's gradient. We found that to be 3/2. When lines are perpendicular, one gradient is the negative reciprocal of the other. So that is telling me that AB's gradient is going to equal to, flip it upside down, you're going to get 2/3, and then change the sign, negative. It's the negative reciprocal of the other. So there it is, we have the gradient for AB already. Remember, the intention is to find the equation for AB, right? We want to find the equation of AB. So I have the gradient, I now need to find that y-intercept. Now, the y-intercept is missing, and it is called our C value, somewhere here, whatever it is. What do we have with a C in it, right? Now, remember that you have y is equal to mx plus c. This is the only thing we have with a c in it right now. So what do we need? We need the gradient to go where m is, and we want a point to substitute where the y is and where the x is. The point is going to be our lifesaver. This is 6, 2. So that line AB passes through 6, 2, where 6 is x and the 2 is y. I am now able to substitute a point and the gradient to get C. Let's go. Y is 2, so 2 is equal to m, negative 2/3. New gradient, new line we're focusing on, times 6 plus c. I want to employ some canceling. 3 into itself, 1. 3 into 6, 2. Take your time. 2 is equal to 2 times negative 2, negative 4 plus c. We are almost there. We're going to add 4 to both sides now. Plus 4 plus 4. We get 6 is equal to c. Right? So now that I have, if I have c and m, the equation is going to be this. This is my m, this is my c. The equation will be y equal to negative 2/3 x with a positive 6 right here. That's the equation of the line A. It's perpendicular to PQ, and it passes through the point 6, 2. All right. So that is how you put it together. Understand that there's a relationship between lines that are perpendicular. There is a relationship between them. And then you could use that with a point that it passes through. And guess what? You can never solve the problem unless it passes through a point. Nobody can. So they will always have to tell you a point that it passes through. And then you use that with the gradient to write the equation of the line. All right. Coordinate geometry, done. And they did ask a number of questions, checking on a number of things. They have a lot more questions that they can ask, but guess what? You could get all of those marks easily. All right, so we're looking at a quick measurement question now. This one has to do with, it's a serial box. I might work this one on the other page. Let's see if I have to, all right, I'm gonna put it there. All right, so this one says a company, let me blow it up a little bigger. If I can, maybe, yeah. It says a company makes cereal box in the shape of a right prism, all right? So yes, this is a prism, all right? Because you're looking at twin faces, what we call that uniform shape that exists throughout, right? So we have that twin, so it's a prism. Here is the deal. We have the dimension of 25 by 8 by 36 centimeters. Each box has dimension they tell you. Now watch this now. Here's a question. Calculate in cubic centimeters one large cereal box. The volume. We can calculate the volume easily of the large, all right? So let me write this. The volume of the large cereal box. Concept, I'll write it. I'll say this to you. I'll write it as this area of cross-section times height, area of cross-section times height. All right, so area of cross-section times height. So what are we talking about now? We're talking about this here, the 25 and the 8. A lot of people might say area of the base. All right, and this base is a cross-section. That is why I said it, right? So you're gonna be 25 times 8, and you multiply that by 36, just like that. 25 times 8. So we're going 25 times 8 times, did I say 36? I want to make sure that we're not erroring. 36. Very good. So let's put those out. Guys, remember to like, right? Subscribe to the channel and like.
7,200.
Thank you very much for that. 7,200, right? So this is actually the volume of that large cereal box. Question 1 down, very straightforward, right? All right, so we have that question 1 down very easily. Let's see what the next question says. Calculate the total surface area of the cereal box. All right, so we want to talk about the total surface area now. We want to discuss the idea, and then we could put it together right where we are, right? So I think it's the B part. We're going to put the B part here so that everybody could be seeing what we're handling, what we're dealing with right now. Let's go for it. So we're suggesting that the total surface area is defined, or the area, but it has 3 sets of twins. This one at the bottom is the twin to this at the top. So when I find the 25 by 8, I'm going to double that. Now, this one at the side here, which is the 8 by 36, has its twin on the other side right there. Also, let me see if I could pick another color, might help a little bit. This one at the back, all the way at the back, it is actually a 25 by 36. It has a twin on the front. It says a twin on the front. All right. So what we're going to do is to put together only 3 sets of measurement and double. 3 sets, and we're going to double. Let's go for it. Firstly, let's deal with the bottom, number 1. It's going to be 25 times 8, and it's 2 of them. Plus, let's go at the side, 8 by 36, and it's 2 of them. Plus 25 by 36, which is the big one at the front, and it's at the back. It's 2 of them. Now let's put together the numbers so no error is being made. 25 times 8 times 2, that's about 400, I believe. Double check with me. 8 times 36 times 2, 576. Double check. 25 times 36 times 2, that's about 1,800. Yeah. And then let's add everything up. 1,800 plus 576 plus 400, and we're getting 2,776 cm square. Context of the question: total surface area. Make sure that we're using the appropriate units as we go. All right, are we good there? All right. Going. All right, so the total surface area, we have that. Calculate total surface area of one large cereal box, 1. All right, now let's take a look at the next question. Come on, let's take a look at the next question. Hold on, let me see where this is. All right, let's put it up. All right, there the question is. So here's the question. Question said the cereal from one large box can exactly fill 6 small boxes, right? Pay attention to details now. Each of equal volume, right? So it's like you have that big cereal box that you could throw out into some small ones, and they're saying that the cereal could fill 6 So now for the CI, it is saying calculate the volume. Context, not total surface area, volume of one small area. Volume of one small. So we're looking at this question. Concept, volume of one small cereal box. You're going to take into consideration that one of this, yeah, one small is going to equal to the volume of the large divided by 6. So you're talking about 7,200 divided by 6, because they did say it could fill 6. You're going to get 1,200 cm3. So it can actually fill 6. So you divide it by 6. Straightforward, and you get the volume for 1. Are we good with that? Yeah? Divided by 6. Yeah, man, you divide it by 6 and you get the volume for 1. No stress. You get your 2 marks and you go. Now, here is a little thing that they want to throw in to test your reasoning, your understanding. It says, if the height of a small box is 20, the height is 20, you know, right? List 2 different pairs of values which the company can use for the length and the width. All right. Now the height is 20. Let's go back to this. What they're suggesting to you is that you have a box. Small one. They are saying it is 20 high. Yeah. Now, they're asking you, what could this be? The length and the width. But before we go there, we're gonna understand that we have the volume for this box and we have the height. And then we're going to manipulate that to get the area of this yellow piece. And then when I get the area of that yellow piece, all I need to do now is to find 2 sets of numbers that could give me that value and tell the company that you could use these. So it's like they're taking you backwards. They want you to understand and relate to the fact that the volume is area of cross-section or the base times the height. So then let us list what we have. Now, that is what we're working with. For the volume, we have, I'm writing a $sign. Guys, don't you see that I wrote a $sign right here? For the volume, we have 1,200. I wrote a $sign just now. All right. Now, the height is 20. Put things into perspective. In reality, the volume of the cereal is equal to cross-section area times height. In this context, you want to utilize what you have and substitute. Focusing on this part, this is what you want to find. You would understand that this is the base, if you want to look at it as the base. So what you're suggesting is that 1,200 is equal to 20 times, not 20, cross-section times 20. Let me put it like that. So as you could see, I could find the cross-section area now. I divide by 20. Why am I taking this long? I'm giving you the right idea. I don't want to jump. So you divide by 20. So you're seeing 1,200 divided by 20. You're getting 60. You know what that 60 is? 60 is the area of this, or you could say the area of that. So notice now the cross section area is 60 cm squared. Now look at what the question says. I'm going to go back to it. List 2 different pairs of values that the company could use for the length and the width of the small box. Let's go back. In other words, we want to list 2 set of numbers that can be multiplied to give 60. So we're talking about a length times a width to give 60. 2 times we want to do that. 2 pairs. Up to you. I'll give 1. I could say a 5 times a 12.
Don't want any more.
15 by 4.
15 by 4.
20 by
20 by 3. 30 by 2. So as long as you want, so the main idea is, am I understanding what they want from me? Eh? Want to mute? All right. Minute your way ask. Okay. All right. So as you could see that it's just understanding the question because you have a lot of options just now. So I'm just saying here's 2. 5 times 12, 15 times that, because they never even gave us like restrictions to say it's not supposed to be this long or whatever. They just leave it open. 20 by 3, people just saying 30 by 2, people finding all sorts of things. The main thing is those 2 numbers multiply to give 60 and you're gone. All right, guys. Very good working, very good thinking. All right, let's continue. More questions coming. I wonder what this one is about. This one is about transformation. And when they're giving transformation, you could take a good look. They are not going to give you 1. The minimum amount of transformation you will get from them is 3 different types. At least 3 different types of transformation you're going to get from them at any one time. It must be more, right? It must be more. So let us now view what they want. So we're looking at the diagram. All right, good. Seeing a lot of things there. Let us see what they want. Let's go. Here's the first question. Let me blow it up a little bigger for us. The first question says, L is mapped onto M by a translation. State in the form, this is a column vector form. Yeah, the vector represents the translation. So they're telling us L to M is a translation. Find the translation, give us. So the T is equal to what? This translation is what? Let's take a look at it. L to M. Take a look. L to M. Here it is. I'll mark it and remove it. We're moving like that, right? Now it's already a translation. Now, so then, based on what we have, this is our object, this is our image, right? So let us now just pick on ideas. I'll say to you, I'm going to pick on the vertices. Look, I will be picking on that spot and see how it reaches there. Now in the exam, I'll say this in the exam. Go ahead. Somebody was asking something. Go ahead.
No, sir, I was telling you it is 4, 4.
Okay, okay, all right. I'm gonna look. So here's the deal. You have 3 things to pick on, please, because they already tell you that it is a translation. It's not like you are going to translate the thing yourself. It's done already. So you don't need to do more than 1 pair. If it was not there, you would have had to do all 3 vertices and draw back your triangle. But you're not doing that. So you're just proving what it is. 1 is enough. So if I'm going to pick on this point, I'm going to see how it reached there. That's all. Now remember, you have to move horizontally before you could move vertically. So let's try to line up ourselves. 1, 2, 3, 4. So we would have moved 4 places to the right. That means my top number is a positive 4. Then I'm going to go up. 1, 2, 3, 4. My bottom number is also a positive 4. Remember, when you go to the right, it's a positive number. If you go to the left, it's a negative number. If you go up, it's positive, but if you go down, it's negative. I had a right and I had a up. So My motion was I went this way, I went that way, and then I went that way. Those are both positive motion, right? So it's a 4-4. I'm going to take it off because I'm going to be using this space. So 4-4, and that is the movement that you want to show, right? 4-4. T is equal to 4-4. Easily, right? Now let's go to the next question. The next question says, L is mapped onto N by an enlargement. See, they're telling you this time, lucky you, you're being told that this is an enlargement, right? L to N. They want you now to do some things. Find and label on your answer sheet the point G, right? The center of the enlargement. Show your method clearly. You see this? That is to show your method clearly. You have to show the lines that would have, met, or the lines that need to show us that this is where G is. So you're going to mark this part G. Let's go back to it. Now remember, if you're going to find the center of an enlargement, you need to pick on some corresponding spots, at least 2 sets, and you're going to run straight lines through them where the lines intersect. That is the center. So let me mark what I'm going to do. I'm going to run a line from here to here, and then I'm going to run from down here to here. Let's do it. All right. So look at that. I'm linking the corresponding spots, right? That's one. I'm going to go for another. Go for another. There it is. There is the other. I don't need to do all 3. I only need to do 2 sets of corresponding points. And then wherever they intersect, you're seeing it with your eyes, they did intersect right here. They asked us to call this G, right? G. So I'm going to look to see if they asked us for the coordinate right now. Hold on. Hold on, where the question? Oh, I think I'm at the question. I'm where the question is. Oh, see that? For now, they wanted us to do this. Find it, show your method with the line, and call it G, right here. That's all they asked for that moment. So what we did there was just find, we do that, you look at it, I call it G. You're looking at it, you're seeing that, hey, there is my G, fine. Now the next question, which is the follow-up from that, is saying like, take a look now. The next one says, state the coordinate of G. No problem. We're gonna go at G. We're gonna read off our point. And our G, as you could see, is where -5 would have met a 0. So that is our G. It is a point on the x-axis. It's where -5 meets 0. And we're gonna be writing that right here. -5 meets 0. The next one says, state the scale factor of the enlargement. Now, when you're going to state the scale factor, you need to understand which one is the image, which one is the object, please. If not, you'll get the inverse. You'll get you will actually get the reciprocal off. All right. So watch this. It says L is mapped onto. So L is the object, N is the image. L is mapped onto N by the enlargement. So L object, N image. All right. So object, image. Remember that when you're finding your scale factor, let me write it. Your scalar factor or your scale factor is going to be an idea for your image divided by a corresponding idea for your object. So we could use a number of things. We could focus on these sides. You could focus on these corresponding sides right there. Or if you don't like those sides, what if you're picky? Then you could focus on these corresponding sides right there in blue. And there are other things, but let's stop. We could focus on any one of those two, right? You'll get the same answer. So let us say that I'm looking at the green. What's the length of this side from here to here? 1, 2, 3, 4. So the image goes on the top, corresponding side in green, 1, 2 over 2. The answer is 2. If you never like those, what if the blue one? 1, 2, 3, 4, 5, 6. You would have gotten 6 at the top from the image first, then 1, 2, 3, object 3. You divide, you still get 2. So it doesn't matter what angle you take it from, you would have gotten the exact thing. The scale factor is 2, and you're done. Let us see if they have anything else for us. Scale factor is 2. All right. No. Write out the word scale factor. Let me write it. Good. Most times I call it K, but there's no mention of it being K. All right, so just write out scale factor equal to. All right. Take a look again. Take a look again if you want to take a nice look at how you map up this. I mean, whenever the questions come, take your time and go through them and collect the marks. I charge you to collect all marks from these questions. Focus. All right, let's go. We're looking at a cumulative frequency question now. Statistics, trying to do as much ideas as possible. All right, in this last class before the exam. So we say here that the table below shows the distribution of marks on a test for a group of 70 students. 70, you know. All right, so we know that total is 70. This number here, 70 students. Now watch this. Question says, complete the cumulative, copy and complete the cumulative frequency distribution. Remember that the cumulative frequency distribution is like this. You will start with the first number, they did that for you. Then you're going to add that 2 to the 5 next below, and you get the 7. Then you add the 7 to the 9, you get 16. So now you're going to add the 16 to the 14, and you're going to get 30. Then you're going to add 30 to 16, and you're going to get 46. Then you're going to add 46 to 12, and you're going to get 58. Then you're going to add 58 to 8, and you are going to get 66. And if you double check it, 66 plus 4 give you 70. All right. So the numbers you put in, you could just do that, and you collect 2 marks for that. 2 marks to fill in your 30, your 46, your 58, and your 66, and there it is. So the cumulative frequency is adding. Cumulative, the word cumulative, accumulate. So be adding. All right.
Sir, go back over that thing.
All right. Now, I was saying that the cumulative frequency, here's the word, cumulative frequency. You add. All right, you're going to be adding going down. Adding going down. So what we're suggesting is you're adding up your frequency going down. So for the cumulative frequency, you'll start, let me change this to blue. You would have started here with that number. First number you start with. Then you take that number, you're going to add it to the one below. So the 2 plus the 5 gives you 7. See that? Then you take the 7 and add to the frequency below. 9. 7 plus 9, 16. Then you take that 16 and add to the frequency below. 16 plus 14, 30. Then you take that 30 and add to the frequency below. 30 plus 16, 46. Then you take that 46 and add to the frequency below 12, 58. 58 plus 8, 66. You're done. But you could just double check again.
I understand
66
now.
plus 4. Very good. 66 plus the 4, 70. So it's called a cumulative frequency, right? Very good. Let me take off these lines for now, since we're going to be doing some stuff right here. All right. All right, there it is. It's a cumulative frequency. All right, nicely sorted. All right, let us see what else they want us to do. Let us see what else they're giving the marks for. The next question says, this is the B part. Now we're going to be drawing something. It says, using a scale of 1 centimeter to represent 5 marks on the horizontal axis. Horizontal is x-axis. 1 centimeter to represent 5 students on the vertical. Vertical is y-axis. Draw the cumulative frequency curve for the scores. Guys, look at marks. Marks giving away 5 marks. So here is the idea. Remember that your cumulative frequency, the one that we're doing is done against the upper boundary. So the cumulative frequency curve you're going to do, you're going to need the upper boundary along with the cumulative frequency. Remember, not the frequency, cumulative frequency. I will highlight it. Look at this. That's what you're using. Upper boundary, work with me. 10.5, let's put it on. 20.5, 30.5, 40.5, upper boundary, adding 0.5 to the upper limit, 50.5, 60.5, 70.5, 80.5. Those are the upper boundaries, and you're going to be using them with the cumulative frequency in that row. For example, you're going to use the 10.5 to go with number 2 over there. Let me change this to maybe a black. All right, black. And then the 20.5 will go with 7. 30.5 will go with 16. 40.5 will go with 30. So you should see the point that I'm making. You're doing cumulative frequency. So the upper boundary go with the cumulative frequency. I have seen too many times when students use it with the frequency and you will not get the curve. Now,
Sir?
in your mind, go ahead.
Sorry, sir. My device shut off just now, so I did not see how. Well, I know that the part where that word there, frequency, cumulative. I know it's
Cumulative
called
frequency.
addition, right? But for the part over here where the mark is, I
Upper
am
boundary.
lost.
All right. This is the upper boundary. Remember the upper boundary. This is the upper boundary. Your cumulative frequency curve is done with the upper boundary along with the cumulative frequency. This one that we're doing. So in red, I put the upper boundary in red because you're going to plot the upper boundary with the cumulative frequency. This is how it is done. So you have to make note of that. Is the upper boundary you're going to be using, all right, along with these other numbers here to plot the curve. That is all. So that is something that you have to note. Make a note, write it down. So how do you find the upper boundary? You add 0.5 to your numbers there. So 10, you add 0.5, 10.5, add 0.5 to 20, 20.5, and you continue doing that. So you're just simply adding 0.5 to create the upper boundary.
Oh, it's
And
like
then
a formula here that you have to actually know the formula. So
well,
you know
it's
that,
not, I don't want to say it's a formula. The upper boundary is just simply
like,
to add a
like it
0.5.
actually, because you said the 0.5 have to be added. And I
Yeah,
don't
man,
see
so-
anywhere the place that there's a 0.5 should be used. So I'm saying that we just have to know that in our head that we add a 0.5.
Yes, it's a
Okay,
principle
that's
that you have to know.
All right, thank you.
All right, good. All right, let's continue. All right, good question. All right. Now, remember now, we rule up the graph. I think I did it. All right, so that's the ruling up. we were told that 1 centimeter to 5. So that's it, I have it. 1 centimeter to 5, you're looking at it. What I'm gonna do now is to plot, right? So I'm gonna grab quickly. I need to have a quick visual of the numbers that I'm going to be using. Maybe you have it, you screenshot, you do something already, but I need to have a quick visual of all right. I'm just gonna grab my values and then we go. Let's go. All right, so I'm not gonna come back to the table. All right. All right, so I don't wanna go up, down, up, down. I'm just gonna deal with it now. So based on the scale, it's 1 centimeter to 5. We're now gonna be plotting our upper boundaries along with the cumulative frequency. I'm gonna blow this up for a little. Watch this now. Remember, you're not gonna see the 0.5s on your axis. You're gonna have to know where it is. You can simply know where it is by understanding the scale that you're dealing with. I'll blow up one spot, then we could talk about it and we just move on. There it is. So I'm gonna maximize blowing this up in our face so we could see what each of those little lines represent. Let me see how big I could get. There it is, very big. I am saying each of these lines that we have, and when I said each of these lines, I'm referring to these. Let me change the marker. Like here, 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 here. They have values. As you move from 0 going towards 5, you need to know what they mean. So I'm saying to you, imagine that this gap from here to here, it's 5 units. That's a 0 to a 5, that's 5. You wanna divide it by the equal spaces you're seeing. Check it out. 1, 2, 3, 4, 5 equal spaces you're seeing. You know? So that means we're saying that you divide it by 5. So if you divide it by 5, 5 into itself 1, 5 into itself 1, it is telling you that one of these lines represent 1 unit. So then, if 5 is here, that means 6 is here. I'm just saying. So 5.5 will be halfway. If 10 is here, that means 11 is beside it. 10.5 is on an empty spot between 11 and 10. I'm just saying. So that means our 10.5 and 20.5, they will be in an empty spot beside the 10 and the 20 and so on and so forth. So we figure out that. Let's just continue working. Let me just clear up my board a little bit. All right, right there. Let's go. Let's minimize this and then let's start the plotting. Let's go. What are we going to be plotting now? We are going to be plotting. We will be plotting 10.5 with 2. 10.5 with 2 is right here. 10.5 is in the empty gap. And 2 little lines is 2. Next movement, 20.5 with 7. Right here. 30.5 with 16. 16 right here. 40.5 with 30. 50.5 with 46. Hold on. 50.5 with 46. Make sure that you're on point. 60.5 with 58. All right, let me pull down this a little bit. Let me take off that so I could, all right, I could see my 58 now. Let me go again. 60.5 with 58. Next, 70.5 with 66. $80.5 with 70. There it is. And you could see the shape already. Now let's try to create that shape. Let me put back a pen, which one I want. All right, hold on, guys. Let me find, maybe a black one could work. Maybe. All right, let's go. I'm using my free hand, so. See with me? All right, that one miss. All right. All right. All right, so basically that's my cumulative frequency right there. A little bit ugly. Software is kind of shaky right now, but I'll work with that. All right, I'm gonna work with that. Oh, Kevin, it's a mixed thing. Many years, right? Mix up years. So it's not a particular year. I selected different questions from different years and using them, all right?
Okay, sir.
All right, good. All right, so there it is, that we have our cumulative frequency there, like that. Now you will get 5 marks to do this, right? 5 marks, and you're good to go. Remember, you cannot use a ruler to do these. It's a cumulative frequency, it's a freehand. You take your time, just connect dots, and that's the sort of shape you want to look for, all right? So good to go. Let's see what the next question is. So now they're going to ask you questions like, watch this. They said, what assumption have you made in drawing your curve through 0, 0? Now I'm going to draw it through 0, 0, right? Let's draw it through 0, 0 here. Watch this. So they are saying, what assumption you made when you draw it through 0, 0? Now, what is the context of the question? The context of the question is that we're dealing with some scores from a test and we're dealing with the number of students. Now, if I draw my curve through 0, 0, I am assuming that nobody got 0 because 0 means 0 students for 0 marks. So that's what 0, 0 there would represent. No student got 0. So they're saying that if I draw it through 0, 0, I am assuming that nobody got 0, which would have been true. Because it would have been 0 meet 0. That means no student got 0. That's what they're saying. So for this one. So what's the question? What assumption you made in drawing your graph to the point 0, 0? The assumption is that no student got 0. That's the assumption. 0 students with 0 mark. All right? Nobody. So they give you 1 mark to see if you understand what that means. Continue working. All right, we're going to decorate this diagram now. It says the pass mark for the test is 47%. This is key. Use your graph to determine the number of students who pass. 47. So now we're going to navigate. We're going to have to take a straight line. Find 47, right? We're going to take a straight line. Let's go for it. Here is a straight line. We're going to take a straight line, find 47, and we're going to take it until it touches the curve. And right where it touches the curve, you stop. Then we're going to take this line across the y-axis to know the number of students. Now I'm seeing there, but now you're gonna have to think it. This is not the answer. Yes, go ahead.
Like, for example, to get a question like this, and we're supposed to mark on the graph, do we use dotted lines or straight lines?
Dotted lines, broken lines. Yeah. And sometimes they will tell you. So it's broken lines. Good. All right. So now you realize that this came across at 41. But guys, think about the question. They didn't say those who got lower than 47. Because if 47 is a pass mark, you'd have gotten 47 or more. So you want to know how many students would have been between 70 to 41. 41 students got below enough. So you have to take the 41 from the 70, right? To know, have an understanding of how many students pass. It's only 29% pass the test. 41, somebody get lower grade than 47. I hope you understand the context, right? Talking about those who pass. So in this case, I think the question is here. I could put right there. In this case, I got 41, so it is 70 minus that 41, and I'm gonna get 29 students. Use your graph to determine how many students pass the test. It went across the 41. That's not the answer because we're going over. We're talking about pass mark, which is higher, and that's the key. Understanding the nature of what you're dealing with, please. All right. So I don't want you to just try it and get the 41 and write it and go on. Read the question slowly, see what they want, understand it, interpret it, and you're good. All right. Next question. So here's the next question now. What is the probability that a student chosen at random had a mark less than or equal to 30? Here is a nice idea. Less than or equal to 30, right? What is the probability that a student would have a mark less than or equal to 30? I am going to find 30 marks. So let's blow this one up nice and easy. 30. You grab your 30. All right, so you grab your 30 there, and you take it across. Hold on. All right. It's good enough. 15. All right. So you take it to 30, pick it off. We're seeing 15. But remember, no, because they said, look at the question. They did say less than. So you'll understand that it is 15. From there, going down to the ground is 15 because the question focusing on less than. But remember, it's probability. So we got 15. Look at the question. Less than. So it's underneath. So it's 15, not over. Underneath 15. But the key word now is probability. It's 15 out of how many students? 70. All right. And that's the answer. If you want to break it down, fine. But they didn't ask for that. So you don't necessarily need to break down anything. But if you want to break it down, you could divide by 5. You will get 3 over 14. Same thing as that, right? So 15 over 70. So the key thing, you want to make sure that you did not just write 15. You write 15 as a fraction, right? You write it of 70, right? It's probability. So they always have a 1 probability question at the end, you know, of your statistics, you know.
Put it as a percentage.
If all right, you're asking if you could put percentage. If you could,
yes, I change it.
All right, yes, you can. But I'll say to you, it would be a waste of your time to do that because they are accepting the fraction as a probability already. So it's like, you know what I mean? You need time in your exam. So you don't even want, even I wouldn't even cancel on this. Why? Because there is no instruction that says to its lowest term. If instruction said lowest term, I would have done this part. But it's because they didn't say that, 15/70 and go to the next question, because you're not gonna get any extra marks if you change it to percentage or if you change it to decimal. So it's like you're wasting a little bit more time that you could start another question, but it will be correct still. So you decide, but I would not, unless I'm forced to by the question. All right? But you can. All right, pushing further. All right, so here is a question. All right, I think this, all right, based on what you have here, this could come in the algebra, function, relation, and graph. Why? Because this don't come in section 1. That's completing the square. So that's definitely a section 2 part of the paper. This would have come, even though you see the transposition. It's because it comes under the algebra, function, and relation, and graph, right? So now let's see what they want us to do there. I'm going to take this one to the other board. Help me write. So I think it is P over 2. All right. P over 2 is equal to T plus R over G. I think the square root sign covers everything. Double checking. Very important. Yes, it is. Here we go. What do we want? T. We're going to make T the subject. All right. So they're giving you this, maybe a 2-mark question. All right. So here's the deal. When I get these questions and I take a quick look, I'm noticing that every single thing on the right side, and I want to find T, is fully covered. Because of that, the first move I'll make is to get rid of the square. If I'm going to try to get rid of the square root, I will have to square the right side. But if I square the right side, I need to square the left side for balancing of math. So then I could rewrite what we have. I'm gonna flesh this out. So it's gonna be P squared over 4, which is equal to T plus R over G. That's what I have right. Now, intention is to find T. I'm gonna keep highlighting it. At this moment, I'm not stressing anything. There are numerous ways to work these problems, but I'm giving you ideas. I'm gonna get rid of this G on the right side. I don't need to trouble the 4. It's not affecting what I want. So what I'm gonna do with the G, I'm gonna multiply both sides by G so that the G here cancels itself on the right side. I'm going to clean up what the left side looks like. I'm going to put it up top here. So up top, I'm going to have G P squared over 4, which is now equal to T plus R. All right. Now, the last move I'm going to make is to remember I need to leave that alone. So I'm going to subtract R from both sides. I'm going to rewrite this so it looks clearer. You would have G P squared divided by 4. This is way different. I don't want you to think that the 4 is the minus R is a part of the denominator, the numerator. It's not. Let me repeat. The minus R is not a part of that fraction. So it's different. And then the T is standing alone. There it is, you're finished. If you want to turn things around and say T equal, it's fine. But it is a T is equal to G P squared minus R, right? You can rewrite it like that if you want. It's fine. But it's okay here. It's also okay here. It's up to you. Nobody will crucify it. So with transposing right here, just taking your time, making sure that you're not making any errors as you go and you flow. If you want to ask if I had to put the square there, had to, no. I did it because it was very simple. P squared P and 2 squared is 4. So it was a very simple move. So I just took it so that I have less complex ideas going forward. Let's take another look. So now they are saying to us here, express the function f of x is equal to 2x squared minus 4x minus 13 in the form f of x is equal to a, open bracket, x plus h all square plus k. This is called completing the square. And it's also a right squared. Completing the square. Let me take this off, back. All right, and it's also called standard form too. Sometimes they'll do that. All right, so let us take a look at completing the square. So we're looking at 2x squared minus 4x minus 13. Let's go. I think I wrote the wrong thing. 13. All right, there it is, 2x squared minus 4x minus 13. I want to put it in the form a, open bracket, x plus h all square plus k. I'll say this to you. There are diverse ways of doing this. I'm going to do it one way right now in the interest of time. Just one way. All right. You do notice that when you complete the square, all you need to find is a value for the h and a value for the k. The plus does not have a meaning there. Don't worry yourself. Any number you get for h, it goes right there in the bracket. The number for k goes out there. And a will be 2 already, so I know what that is going to be. I am suggesting that we can simply use a formula to find h and k and collect the marks, no stress. That's one of the easier ways to go. So I'll say h is equal to b over 2a. So what we want to do is to write down what is a, what is b, what is c. So I'll do that now. A is the coefficient of the square. So it is going to be 2. B is going to be -4. And C is -13. So then if I'm supposed to find h by doing b over 4 over 2a, then simply it's going to be -4 over 2 times 2, which is -4 over 4. H is -1. I have a value for that already. That's what I'm suggesting. Now, k can be found by doing this. There are two formulas. You have a 4ac minus b squared all over 4a. Some people might say you can use, if you want, c minus b squared and the b squared over 4a. It's up to you. I like to use this one that looks more complicated, but it's not. All right, you're gonna, so 4, so I'm just gonna go with the first one. 4 times a times c minus b squared all over 4 times a. Continue. Calculator at work now. 4 times 2 times -13. That's -104. You're going to minus 16 divide by 8. -4, 104 minus 16. That's -120 over 8. And we're getting something like about -15. Can confirm with me. K is -15. Confirm quickly. I believe it is. 4 2 is 8. 8 times 13, 104.
That's right.
All right, good. So now that I know what H and K is, I am saying, look what you do with this. A goes outside. See there? So A is going to go to your 2, open bracket. X will always be here. H is -1. Square will always be there. The value for K is -15. Let me write back my 15 better. I'm suggesting that we only did this. And we put that. That's it. The rest of things were there already. X will always be X. The bracket will be there and the square will be there. So that's why I'm saying that I think in this exam, you could just easily employ the formula to get these values, put them in. Outside of that, you'll be doing a nice little algebraic workout. So if you don't want to do that, then you could easily just do your completing the square by finding your K and your H. And they do have meaning. So let us see what they mean now. So that is it. Let's see how much marks we get for that. 3 marks to do that. Hence or otherwise. Well, I like this because we're able to just start answering questions, right? It says we want to determine the values of X at which the graph cuts, all right? The X-axis. The value of X at which it cuts the X-axis. When you cut the X-axis, do you know that is X-intercept they want? They want X-intercept. X-intercept. All right. So when you cut the X-axis, that's X-intercept. Another way of saying that is to solve for X. I'm just saying this thing that they said here, that's what it means. Right? So the X-intercept is to solve. So if you want to solve this, look at this. You want to solve this. It says here, 2x minus 1 square minus 15. Let it equal to 0. If you're going to solve it. As long as it's quadratic, you solve it, you let it equal to 0. And then you start solving. Watch. Regular. Add 15 to both sides. Don't pretend too much. Don't do too much. See it there? Get rid of the 2. Divide by 2. So if you want to call this 7.5, that's okay. All right. How do you get rid of the square? Take the square root. See there? Take the square root, so you're left with x minus 1. Now, the moment you take the square root, you're going to have to put a plus or a minus in front of it, and that's where it comes from. So let us find the square root of 7.5. I'm going to use like 2dp, so it's going to be 2.74. So I have a plus or minus 2.74. We're almost done enough. Look at this now. How do you get rid of the 1? It's negative. I add and I add. That means it's going to be a positive 1 on this side right there. I'm putting it right there so it looks nice. Look at what I have. Check this out. I have x is equal to 1, which is a positive 1, plus or minus 2.74. See that? You know what that means? Either x is equal to 1 plus 2.74 or 1 minus 2.74. Let's figure that out quickly. So the first one here, x is 3.74. And then the next one, you want to subtract. So you get or minus 1.74. There it is. What I'm saying is you're solving it like you're transposing. Don't look at the things and feel worried. Just do what you have to do. Get rid of the 15, balance. Get rid of the 2, balance. Get rid of the square, balance. Get rid of the 1, balance. Sort out the math. Just flow in your confidence and in everything that you learn already and get these things out. Right? Trust me, it works.
Sir,
Go ahead.
what if I had used like the first quadratic? Would that be wrong?
No.
The one that was given?
No, it wouldn't be wrong. Let me tell you why it wouldn't be wrong. Because they said ends are otherwise. You would be right because of this word here. You get it? Right? But if that word was
Yes,
not
sir.
there, if that word was not there, you can't do anything. So definitely you could use this too. Based on the fact that you knew where it's coming from, fine. And this word would have helped you there, that word, otherwise. Good to go? All right, good. All right, let's look at the next one. This one right there. All right, the interval for which f of x is less than or equal to 0, right? Intervals for which f of x is less than or equal to 0. All right, this question is very deep and I'm going to go through with it. In order for you to determine that, you probably want to have a quick sketch so that you could see what you're doing. Just a quick little sketch of what this curve look like. But when you complete the square, you're able to sketch. You're able to see everything. So I'm going to sketch it so that you could see and then you could pick some stuff from it, because you won't be able to pick the intervals without having the graph. And when you complete the square, enough information is there for you to do a sketch. For example, look at this. All right, I'm gonna put it, where do I put it? Anywhere. So I'm gonna drop it here. So when I'm going to do a sketch, I just rule up a little thing like that, right? Sketch. X-axis, X and Y, put them. Now, when you complete this square, you take this, or you could look at the opposite value for H to know where the axis of symmetry is. This part links to the axis of symmetry, that. So if X minus 1 is equal to 0, you could find the axis of symmetry there. The axis of symmetry is the opposite of any number here. So it's gonna be X equal to positive 1. Axis of symmetry is over here. So I'm just making, remember it's a sketch. So this is where X is equal to positive 1 right here. Right, so right there. So that's the axis of symmetry. When you complete the square, the number you get out here is the minimum or the maximum. Remember now, the A value tell you if it is minimum or maximum. In other words, let me see if I can relate to you. If your A value is positive, your curve will smile. You know that when things are positive, you smile, right? So if the A value is positive, your curve will smile, which means that you have a minimum, see that? But if your A value is negative, your curve will frown, which means that you have a maximum. So you could use that to help you, right? So I have some negative 15 somewhere down there. Remember, it's a sketch. So this is negative 15. So negative 15 will meet the axis of symmetry at your minimum because A was positive, so we have a smile. Another thing that we know about this is that it crosses the x-axis. One of them is at negative 1.7 and the other one is at positive 3.74. See that? So now I could draw a sketch. I can draw a sketch right now. Watch. Also, the y-intercept, we know the y-intercept from the original thing. The y-intercept, let me show you. See here? The y-intercept is negative 13. So we know so many things, you know. So that means negative 13 somewhere here on top of negative 15. Just put them in the right place. So watch this now. I'm just saying that's a sketch of what the thing looks like. Now, why I sketch it so that you can have a better, visual of what you're about. Now, if they want to know where the curve is, look, the interval where the curve is less than 0. F of x means y. Guys, f of x means y. It means the curve. It means the graph. So that one f of x there less than 0, they are saying, where is the graph? You understand? Where is the graph in the negative section? the negative section, because less than 0 is a negative. Go back to it. Would you agree that the negative part of the graph that is in the negative section, starts right here, here, and it comes down in this section? All of the part that I'm coloring in green would have represented where the graph is below the 0 for the y-axis. Tell me if I'm lying. Right there. It's under the, remember, it's like you have, look at this. Like you could say y is 4, y is 5, no, y is 3, y is 2, y is 1. This is where y is 0. When y is 0, you're on the x-axis, and then negative. So you start getting negative values going down. So the curve is in the negative when it goes under the y-axis. So it starts right here, right here. So to answer that question, you're going to stand between your two solutions. Look at it. You're going to stand within your two solutions and describe the region. You're less than or equal to 3.7, but you're greater than or equal to negative 1.74. I'm just saying, look at your solution. First, you have to understand where they want, but because they said where f of x is less than or equal to 0, I am saying having a visual, quickly look so you can have an idea. I only sketch it for you to see what's going on. So it's like you're standing here and you're describing your domain that would have caused the graph to go underneath here. So you're saying, oh, positive 3.74 along with negative 1.74. All right. And then you describe that. So you're greater than the smaller one, you're less than the bigger one. That's all. So this question here is referring to that. Let me show you. This question here. The interval where the graph is less than, you would have put x is less than or equal to the thing to your right, the marker to your right, but it's greater than or equal to negative 1.74. That's the marker to your left. Those are your intercept. So you see, when they ask where cut the x-axis, it's the key to lead you to something else that they wanted to ask you. You find it, so they want to know, now, can you use it to help yourself? That's what. Now, flowing still, you want to determine the minimum value. The minimum value is where y is negative 15. Remember, I tell you, this number from the completed square, this, it can be a max or it can be a minimum, depending on what the curve is. This curve only has a minimum. So any number out there will be your minimum right now. So negative 15. So when you have the completed square, you can answer these questions same time. Next, the value of x at which f of x, watch this, you know, the value of x at which f of x is minimum. The only x value at minimum, I don't have to look. It is your axis of symmetry. The only x value at minimum is your axis of symmetry, and it's where x is equal to 1. The only x value at max or min is axis of symmetry, and it is where x is equal to 1. There it is. This question, I believe, it's a nice question, and that is why I kind of picked it, you know, because I haven't seen the completed square, but it is on your syllabus. You might see it on the exam. All right, here's a vector question. Vectors will definitely be at number 10. Number 10 is titled Vector and Matrices. So we have a vector and matrices here to look at. All right, so here's our vector question. It says the diagram below shows two position vectors. So we're dealing with position vectors already. OA and OB. OA and OB. You're looking at the diagram, not so clear, but I think it's fine. Write as a column vector the form x over y. Column vector OA. Well, you could look. Because it's a position vector, the coordinate of A is the position vector. So this one is -1, 3. So OA is where -1 meets 3, right here. OB, take a look, 5 meets 1. We have those. Getting some 1 marks. BA, now we're gonna displace 2 position vectors. We're gonna displace OB and OA. There are 2 ways to do this. I might just do 2. First one, I'll just say, if I want to move from B and end up at A, I'm gonna travel to the common point. So I'm gonna move from B to O. Then I move from O and end up at A. So we're saying that's the sort of motion that we wanna employ as we go. B to O, O to A. Let's write down what we have from B to O. I think I probably should have put this elsewhere. I need space. All right, give me a second. Here it is. All right, so I'm doing BA. And it's going to be from B to O plus from O to A. Remember that OA, if I remember well, it's -1, 3. And OB, if I remember well, I think it is 5, 1. Make sure that it's correct, guys. I could just take a quick look. Yes, -1, 3, 5, 1. Good. Now, let's move. We want to go BO, inverse of OB. So it's going to be a -5 with a -1. Change the direction, you change the component sign. I'm going OA. OA is still -1, 3. What are we looking at there? -5 plus -1, that's -6. -1 plus 3, that's +2. So BA is actually -6, 2, method 1. Now, you could have done it another way.
Excuse me, sir.
Go ahead, this is solution 1.
I didn't get where, how did you get the -5 at B?
All right, take a look. We have the position vector from O to B, which is 5, 1. But we are not going O to B. Based on what we're doing, we're traveling from B to O, the inverse.
Okay.
So because you're going in the opposite direction, the signs of the components must be changed. Anything you see, flip it. If it is positive, let it become negative. If it is a negative, it becomes a positive. So we had 2 positive numbers. So we're going to end up with 2 negative numbers. Are you fine with that?
Yes, sir.
So we have to pay attention to the details in terms of the arrow system that you're dealing with, what you got, what arrow was on it. It's vectors, you know, and the vector only deal with size and arrows, which is direction. So I was saying solution 1, you could have done that. Let's look on a second solution. Solution 2, I could find BA by displacing the 2 position vectors by using the end minus. So we're going to be the end minus start. So the end minus the start. What's the end position vector? A. So you're going to write the OA. So it's going to be the OA minus the OB. End minus start position vectors. The end minus the start. So the end was a A, so it's a OA. And the start was a B, so it's a OB. Put them there. -1, 3 minus 5, 1. Check out the response. -1 minus 5, -6. 3 minus 1, 2. Same answer. So as I said to you, it's up to you. You have method 1, method 2. Anyone you want to employ, both work. I'm not here to tell you which one to choose. Choose the one that works best for you. All right? Take note. All right, let's continue working. Now, there's a question here that says, given that G is the midpoint, so G is the midpoint of BA. Remember, G is the midpoint of BA. Write as a column vector in that form, BG and then OG. All right, let's go back to that. B is the midpoint of G. No, G is the midpoint of AB. So what they're suggesting is you have AB, somewhere here, you have a G, and it is the middle of that. Now, if they ask me to find BG, remember we found BA already. We know what BA is, and they want me to move from B to G. B to G is halfway. So let's write this, BG. They want me to find BG. BG is half of BA because BA was already given, and they told us that G is the midpoint of BA or AB. So B to G is half of it, which means I'm going to have half of -6, 2, which is going to work me back down to -3. All right, let me take my time with you there. I'm going to multiply its half. So it's a half times -6, a half times 2, which is going to work down to -3, 1, right? In other words, then you could just half the things inside. So from B to G is actually -3, 1, half. So we have that. So I don't want you to overthink. You're given something about G and you understand the context. Take it as is, flow. Let's look again. We just found this. Now they want OG. Look at what they want. They want us to find from O to G, this. Following the flow of the diagram. If I'm going from O to G, I'm going to just take my triangular law and walk. I'm going to walk from O to B, then I move from B to G. I'm done. I have those vectors already. I have OB and I just found BG. So I'm going to put together the ideas, man. Don't overthink it, right? So OG, let me put it right here. We could put OG right here. OG is to walk from O to B. Then I'm going to be moving from B to G. Mission accomplished. OB, we knew that already. OB is 5, 1. BG, -3, 1. Finally, 5 plus -3 is 2. 1 plus 1, 2. So we could conclude that OG is 2, 2. There it is. Straightforward thinking, you know, vectors is not what most people make it to be. It's simply a walk. And a lot of times a triangular walk will always help. Always remember, there is a common link. There is a letter that links the beginning and the ending. Line them up, watch the arrow, watch how you flow with the arrow, and if you have to change the component, do it. But remember the arrows are important. Take a look at what you have, what you're given, and then when you decide on making a move, make sure you're putting your things the correct way. All right. That's that. Vector finish. Sometimes the question them nice, eh? Matrices now. It says L and M are 2 points. L and M are two matrices where L is 3, 2, 1, 4, and M is -1, 3, and 0, 2. All right, so we're asked to find, we might can do the, no, I'm going to do them on the other page. All right, so we want to do L plus 2M. All right, let's write what we have. All right. If you want to work it. I'm going to work it in a second. I'm just grabbing a quick picture of what's going on here so that I'm able to, I don't have to be flipping too much. All right, let's go now. 1 second. Let me find what I'm looking for. Oh, I thought I had it. Hold on. I thought I had it. All right, there goes. All right, so let me write that. So L is 3, 2, 1, 4. And then M is -1, 3, and 0, 2. L plus 2M. L plus 2M. Now let's put it together. L you're going to be adding 2M. So this is your L. 2M is 2 with your M. I'm writing it so you could see it. Some of you would move faster. That's fine. So that's your L plus your 2M, which means that you're going to have 3, 2, 1, 4, 2M now. You're going to distribute that 2 inside. Yeah. -2, 6, 0, 4. Put it together. 3 plus -2, 1. 2 plus 6, 8. 1 plus 0, 1. 4 plus 4, 8. There it is. L plus 2M is 1818. Double check it if everything is good. I believe so. It's good. Now the next one says that we need to do LM. LM, which means that we're going to find the product of that. LM. So make sure that you put the right matrix first. L comes first, followed by M. I'll just highlight an idea here. When you multiply, it's going to be rows by columns. So if I should just make a quick note, row 1 at the top, row 2 at the bottom, column 1, column 2. What am I going to be doing? What will I be doing? Row 1 times column 1, then row 1 times column 2, then row 2 times column 1, row 2 times column 2. Row 1 times column 1, let's go. 3 times -1 plus 2 times 0. So that's row 1, column 1. Row 1, column 2. 3 times 3 plus 2 times 2. That's row 2. That's row 1, column 2. Let's go further. Row 2, column 1. 1 times -1 plus 4 times 0. 1 times 3 plus 4 times 2. Always double check, take a look at what you do, because it's easy to make an error while you're doing these. All right. All right, let's finalize that. So I'm going to write 2. So I'm going to go -3 plus 0, 9 plus 4, -1 plus 0, 3 plus 8. I only do this to give myself an extra chance to see errors if it is there. So -3, 13, -1, 11. Double check. There you go. Row by column, row by column, row by column, row by column. All right, and we're good to go. Make sure that you put the right matrix first. If they say LM, do that. Let's keep it going. It says the matrix Q. So the next question says the matrix Q is such, right? So the matrix Q is such, hold on. Matrix Q is such that Q is 4, 2, 1, 1. Find the inverse. All right, let's go back to this. So this is the matrix Q. 4, 2, 1, 1. And we're asked to find Q inverse. Guys, remember, the inverse of Q is going to be 1 over the determinant of Q times the adjoint of Q. So let's find those two things, put them together. Let's go for the determinant of Q. The determinant of Q is simply the product of the main diagonal. There it is. So it's going to be 4 times 1 minus the product of the other diagonal, which is 1 times 2. So what are we looking at? 4 ones, 4 minus 2, it is 2. The determinant is equal to 2. Let's go for the adjoint. How do we find the adjoint of the matrix? The adjoint of the matrix is to switch the elements on the main. So the main is a 4 and a 1, the main diagonal. So it's going to be a 1 and a 4. Switch the elements. Then you change the signs on the other. So positive 2 becomes negative 2. Positive 1 becomes negative 1. Now we have the adjoint of the matrix. Now that we have the adjoint, we can simply say the inverse of Q is 1 over 2 times negative a half 2. That's the inverse. Truth to be told, the moment you set this up, that's the inverse. This is the inverse in a more simplified form. But I've marked this question already, and they gave, like, they would tell her that if a student does this, it is already correct, right? So good to go. All right, let's push further. Let's see if we could go further. So there is our inverse of the matrix Q. 1 over the determinant, multiply that by the adjoint, and we're good. All right. Next question now, it's a follow-up. So what they say here, using a matrix method, find the value of X and Y in the equation. All right. So let me write down this. So we're going to find the value of X and Y. So here it is. They have 4, 2, 1, 1. That's your matrix Q. Yeah. So technically, this is like a simultaneous without them saying it. I'm suggesting that remember how you solve this. If I have a 2 by 2 matrix here, and I have another matrix which is unknown here, and it's equal to another matrix over here, all I have to do is to use the inverse of this matrix here, and we have the inverse already. So you're going to take the inverse, yeah, and put it here. Q inverse, because this is Q. So Q inverse comes beside A3, and you solve the problem. Now, let's continue working. Q inverse, if you don't want to work with fractions, it is fine to use it back in its pure form. 1 over 2. Say, what if you don't want to work with the fraction? You could work with 1 over 2. So I'm putting the inverse in the top, 4 at the bottom. Now watch this now. At the end, xy is equal to, slide the half inside, half of 2, 1, half of 4, 2. And there is our response. X at the top is 1. Y at the bottom is 2. Please bear in mind that there is no fraction here. So anybody that loves to put a line here, you're going to get it incorrect if you do that. Right? Do not put any line there. This is simply saying that this is a 2 by 1 matrix. There is a number there. There is a number there. X is for the top number because X is at the top. Y is for the bottom. Y is at the bottom. So you would have solved that. And that's a complete matrices movement. You would have done all that they require of you to do a matrix. I want you to understand that whenever they set up anything for you to do like simultaneous, they're going to ensure that they have a 2 by 2 matrix then an unknown matrix, which is going to equal to another matrix. But the 2 by 2 matrix always have to come first. Have to come first. So it's not like they have option. They don't have any option. All right. The 2 by 2 matrix will have to come first. Like this is what I'm talking. This is the 2 by 2 matrix here. It has to come first. Then the unknown. Then something else. You can't mix up. You won't be able to work. Mathematically cannot work. So I'm saying you will see a 2 by 2 matrix, then the unknown, then the other matrix. It has to be like that. So no stress, no worries. All right, let's go. Circle. I think we're at the end of the road then. Let me look. I don't think there's anything. All right, this is the last one, guys. Let us hold on. And we're at the end. We have gone 2 hours and 38 minutes. Let's just close it down properly. All right, we're at the end. Let's go. Circle theory. Always come at, this comes at like number 9A. It is there at 9A. May come for 7 or 8 marks. No more, no less. Let's go. It says the diagram below, not drawn to scale, shows a circle with center O. The line BC is a tangent to the circle at B. All right, we're seeing all of that. Angle CBD is 42. We're looking at the 42. Another thing that they say to us is that angle OBE is 20. All right, all the information given is there. Question time. What we want to do is to calculate, and we want to give a reason. This is singular. Give a reason for each step, right? So every step needs some verification. All right, the measure of BOE. BOE. Let's mark the angle first. BOE. Let me take myself off the screen a bit, so I need some space. BOE. BOE. There is your BOE. All right, so that's your BOE. Now, remember that OB is equal to OE. See that? No, 140. Isosceles. So OB is equal to OE. Both of them are, those are radius to that same circle, right? That means the triangle OBE is an isosceles. So this is equal to this, which means 20 degrees is over this side. Now, if I know that, then when I'm ready to do BOE, right, then I'm going to have to say, okay, 180 minus the sum of 20 plus 20. So it's 180 minus 40, and that's 140 degrees. This angle at the center here is 140. All right. So there are two things that I utilize here. One, I utilize the isosceles triangle. And then the second step, I utilize total interior angle of a triangle is 180 degrees. So I utilize those two things and we're good. BOE 140. Next one. So this is 7. So what we say? OED. OED. Let's mark OED right away. OED. Where's O? OED. This. We want this little piece. Now I'm seeing something already, right? I am seeing here that the tangent is now being utilized because remember that an angle between a chord and a tangent, yeah? An angle between a chord and a tangent. Right there. Which is the 42. That angle is equal to the angle in the alternate segment. And when I said alternate segment, I'm going to do a quick sketch over here for you so that you can see what we mean. Look, this is our circle. We have, when the circle is cut by a chord, this is called a segment. So this is like the minor segment, right? So that's the minor segment you're looking at. And then over the other side, hold on, let me draw back this. Hold on, ugly. There it is. So when you cut it with a chord, you'd have a minor segment here. And then over this side is the major segment. So what we're suggesting is that you have to look. If this is formed, if a triangle is formed here, so if some triangle is formed, let me put it in red. This triangle is formed now. Because this chord down here, this one, put this circle in a segment, we are saying if there's a tangent coming anywhere down here, this angle will be the same as the third angle over here. So we're talking about, we want to ensure that we notice that this angle down here, they were already mixed up with this segment here, right? Mute your mics. So this angle down here would have been touching this segment down here. So it's the other angle that does not touch the segment any at all is equal to when the tangent passes out here. So if you take a look here, 42 is going to equal to 42. All of this is 42. Now I can use 42 and 20 to find what I want, because what I want is this little piece. So you can see now how I could put together the different things now to help me to find that. Here it is. First, OED is going to equal to the 42, take away the 20. And you're left with 22 right there. This little piece is 22. So what did I use? I use the alternate segment principle. That's all. If you're at the alternate segment, it's enough information for them to know that, okay, 42 is the alternate segment, and then you subtract that 20 that you had already from it. There goes. Almost done. Last question now for the night. So this is 22. BFE. BFE. This. Well, what you can do right now, though, you can do a few things if you want. I'm seeing two ways. Huh? And a cyclic. Watch this. There are two things you could do. I'm going to clear up the diagram to explain it. Watch. Taking off what I don't need. First, one of the methods is that I could use this angle here and say angle at center is half the angle at the circumference, but I need that reflex angle out there. So I would have to say, guess what? The first move that I'll make is that I would say 360 minus 140, which is 220. So it gives me this angle on the outside here. Because when we say angle at the center, it's going to be on the outside of the shape. And it's going to equal to half the angle inside now. As in the angle opposite to it, not opposite, should say, the angle at the circumference, because we're talking about center and circumference then. So the angle at the circumference is going to be half of that, 110 degrees. This. So that's one approach. All right. So what did I use? I used the total angle in our circle first, which is 360. to get this. And then I use angle at center is 2 times angle at the circumference divided by 2 to get that. That's one way. You know what else I could have done? Let me see if this would work. Okay. Oh yeah, it could. It could work. Yes, it's working. I am seeing another thing. Let me clear up the diagram. Let me show you something else. Look. That's why I said these questions are nice, because you would have option. I'm gonna highlight a triangle. Look at this triangle. Look at that triangle. Now I want you to look at this tangent. This is a chord. This is 90. Everybody know that this is 90. All of that because radius meet tangent at 90. I am saying all of this angle is actually 90 plus 20. It's 110. So all of this angle right here is 110. That angle is an alternate segment angle to this. Look at it. Look at the triangle at the highlight. Coming from tangent to chord. This is the chord now, you know. So the angle between the tangent and the chord is 110. Is going to equal to the angle in the alternate segment. See there? 110. So there are diverse ways to get those answers. So you could have gone there. Could have gone there. And that's the end. All right. People on my Zoom, hold on a bit. All right, guys, we're at the end. I'm about to close the session. Thank you for coming. And we're ending the stream right now. Thank you.